Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 9, 2025, just yesterday. It introduces a motion control method for image-to-video generation that can produce 5-second 480p videos, whose motion controllability rivals Kling 1.5 Pro Motion Brush in user studies. The paper is titled Wan-Move, Motion Controllable Video Generation via Latent Trajectory Guidance. And as we will see later, the approach keeps the model simple while delivering surprisingly precise and flexible motion control. Also, the author shared a GitHub repo for Wan-Move. There you get the full inference code, model setup via requirements in PyProject, scripts for single and multi-GPU generation, the Move Bench evaluation toolkit, and a ready-made example case with images and trajectories, so you can quickly reproduce their controllable videos. On Hugging Face, you'll find the Wan-Move 14 billion parameter weights for 5-second 480p motion-controlled image-to-video generation, plus command-line inference examples. Figure 1 illustrates what Wan-Move actually enables, a single image-to-video system that can follow very different kinds of motion instructions. The left column sketches the motion controls, while the right columns show the resulting video frames, so you see that the visual quality stays high as motion becomes more complex. The first three rows demonstrate multi-object motion, complex articulated motion, and combined object plus camera motion. The next rows highlight finer controls, including primitive-level deformations, motion transfer from abstract patterns, and full three-dimensional rotation of an object. Figure 2 shows how Wan-Move turns user-specified motion paths into guidance inside the video model. The left panel illustrates latent feature replication, where point trajectories in the video get mapped into the model's latent grid, and the first frame features get copied along those paths. This process creates a motion-aware condition feature that already encodes how each object should move. The right pipeline panel then takes both the noisy video latent and this condition feature, concatenates them, and runs standard diffusion transformer blocks to generate a motion-controlled video without changing the base architecture. Figure 3 explains how the Move Bench benchmark gets its high-quality, well-labeled videos. The left panel shows video curation, where raw clips go through expert scoring, automatic processing, clustering, and manual selection so only clean, coherent motion remains. The middle panel illustrates interactive annotation, with humans clicking positive and negative points on objects to define tracks and masks. The right panel presents the final sample contents, which bundle point tracks, object masks, and a rich natural language description of the motion. Table 1 shows that Wan-Move clearly leads on both benchmarks, giving better visual quality and more accurate motion than all competing methods. The Move Bench columns in the middle report image quality scores like Frechet inception distance and peak signal-to-noise ratio, and Wan-Move achieves the best value for every metric. The Davis columns on the right tell the same story, since Wan-Move again scores the lowest motion error and the highest structural similarity. Together, these results suggest that the latent trajectory guidance works robustly across very different video datasets. Table 3 reports win rates from a two-alternative forced-choice human study, where people repeatedly picked which of two videos better matched each criterion. The table lists competing methods on the left, and 3 columns for motion accuracy, motion quality, and visual quality. High numbers here mean that Wan-Move won most pairwise comparisons against that method. The striking pattern is that research baselines already lose heavily, while the commercial Kling system still trails, especially on motion accuracy and motion quality. Alright, wrapping up, 2 takeaways stand out. Latent trajectory guidance lets a standard image-to-video model follow very precise motion controls without extra encoders, and Move Bench gives a solid way to measure that control in practice. This combination pushes controllable video closer to real creative tools. That is it for this episode of AI Research Roundup. I am Alex. Thanks for listening.